Hello, sixth graders. Welcome to your review for unit number 1. I'm going to go through the 5 things that will be on your unit 1 test. Each of these things will be in a different section on your test, and your test is going to look almost identical to the review assignment that I'm giving you in class, except for, of course, the numbers will be a little bit different so that they don't have the same answers. All right, let's start with our first learning target. It says, I can write expressions using exponents. So remember, an exponent is this tiny little number up here, and that little number, let me try that again, up here, there we go. And that little number is saying how many times we multiplied the base, the bigger number. So I always think of the base is the big number, and that's the only number we see in the problem. So we see that 2. And we see it how many times? We see it 1, 2, 3 times. So it's a 2 that we see 3 times. In between, we use multiplication to show that this means 2 times 2 times 2. Just like 2 plus 2 plus 2 is shortened with 2 times 3, 2 times 2 times 2 is shortened with 2 to the 3rd power. So here, this says 3 to the 5th power, which means we see the number 3 and we see it 5 times. So we see 3 times 3, there's 2, 3, 4, 5. And that is how we write it as repeated multiplication. When it says to write it as repeated multiplication, you do not need to evaluate it, which means you do not need to actually multiply it out. You just need to leave it as repeated multiplication, just like that. Okay, the next one says 7 to the 2nd power, or also known as 7 squared. So that means I'm seeing the number 7 and I'm seeing it 2 times. So 7 times 7. Done. And the last one, I see the number 8 and I'm going to write it 4 times. So 8 times 8 times 8 times 8. And that is finished. All right. This is the same target, but this time, instead of writing it as repeated multiplication, we're going to write it the other way. We're going to write it as a base and an exponent. That's what exponential form means, to write it with an exponent. So here I see the number 13. So the number I see is the base, the big number. And I'm going to count how many times do I see it? 1, 2, 3. So I'm going to say 13 to the 3rd power. When I see 2 4s, I'm going to write the number 4, because the number I see is the number I write big. And then I count how many, and that is the little number, the exponent. Again, I'm going to write a 2 because that's the number that I see repeated. And I see it 1, 2, 3, 4, 5, 6 times. So I'm going to write it to the power of 6. The second learning target is I can evaluate exponents. Evaluate is a word we're going to see a ton this year. It means to do the math as far as you can. So here, first I'm going to write it as a multiplication problem. Then I'm going to actually do that multiplication problem. So I wrote a tricky one here, 4 to the 1st power. That means I have a 4 and I see it just one time. So there is no multiplication problem. I'm already done. It seems too easy to be true, but it is. The second one is much trickier. So I have 5 is the number I'm going to write over and over. I'm going to write it 3 times. Okay. And I'm going to do that multiplication problem. So I'm going to say 5 times 5, which is 25. And 25 times 5. I'm thinking about quarters because a quarter is 25 cents. And if I had 4 quarters, it would be $1 or 100 cents. If I had 5 quarters, it would be $1.25 or 125 cents. That helps me in my multiplying that big number 25. I could also write it out and say 25 times 5 and do it the long way there too. All right, the next one is 3 repeated 4 times. Okay, so 3 times 3 is 9. And remember I said you could actually take the next set and you can multiply them like that as long as you multiply these two numbers times each other when you're done. So I could take 3 times 3 and get 9, and then times it by another 3, and then times it by another 3, but it's actually a little bit easier to do it this way, and I get 81. All right, the third learning target. I can solve problems using the order of operations. Remember that we have to do problems in the same order as everyone else, because if we all choose our own order, we'd all end up with different answers, and we can't have that. That's not going to be very helpful. So first, I'm going to write out that parentheses is step 1, exponents is step 2, multiplication and division is step 3. However, it could be divide first, then multiply. We decide based on what comes first, going left to right. And same with step 4, that should say 4. We are going in order from left to right, which might mean that subtraction comes before addition. So these two, that's why they're combined here as one step. It's two things that are in the same step. Okay? All right, so if I do this first problem, I'm looking for parentheses, and I don't see any. So I'm just going to say check. My parentheses are done. So I'm going to move on to step 2, exponents. I do see an exponent. I see 2 to the third power. So I'm going to do that problem. Remember, 2 to the third power means a 2 multiplied by itself 3 times. 2 times 2 is 4. 4 times 2 is 8. So this gets a little messy. I like to rewrite the whole thing. I'm going to say 9 times 5 plus, now instead of writing 2 to the third power, I'm going to write the answer, which was 8 minus 9. Now, I don't have any parentheses, and I'm done with my exponents. So check. I'm moving on to multiplication and division. I see I only have multiplication right here. So I'm going to go ahead and do multiplication next. 9 times 5. That gives me 45 plus 8 minus 9. Okay, and then next I have addition and subtraction. Again, I'm going to go with what comes first. So since addition comes first when I travel from left to right, I'm going to add first, and then I'm going to subtract. So when I add 45 plus 8, I get 53 minus 9 to get 44. All right. I love it when people circle their answers at the bottom so I can tell that that is their final response. This next one, I'm going to change this because when I was looking at this video, I realized that that doesn't really actually work out. That's not going to work out either. Hold on. We'll do 7 minus, we'll keep it 3 to the third power, but then we'll divide it by, let's see, we'll divide it by 9. Okay, so for this problem, I'm going to start with parentheses. Again, there aren't any. I'll move on to exponents, which would be 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So I'm going to write the whole thing over, but instead of this, I'm going to write 27. So 7 minus 27 divided by 9. Okay, check. Now, if you weren't following order of operations and you had this problem here, you would get really stuck because notice 7 minus 27, you might know that that ends up being a negative number, but we haven't learned negative numbers in 6th grade yet. So if you end up with a negative number, that's a good sign that you made a mistake and you should try again and start over. Another good sign you made a mistake is if you end up with a decimal. None of the answers should end up as decimals. You should get whole number answers. So if you're getting something that's not working out, start over and go step by step. Slow it down. Most of the time when someone makes a mistake on these problems, they're just rushing and going too fast and not going first step, then second step, then third step. So I'm on the third step, multiplication and division, which tells me I need to do this problem before I subtract. So 27 divided by 9 is 3. Put this front stuff back on, 7 minus 3. I don't need to look at my order of operations anymore. There's only one operation to do. My answer is 4. Now I had to change this because I would have ended up with 27 divided by 6, and that doesn't work out nicely. So I wanted to make sure it ended up with a nice answer just like you'll get on your test. All right, the last order of operations problem does have parentheses. So I'm going to go ahead and do the problem that's in the parentheses first. If there's more than one thing inside the parentheses, you start with what's in there, and then you go back to the order of operations and say, which thing inside of here do I need to do first? So I've got 9 minus 5, which is 4. So let's rewrite this. 8 squared minus, now I can take the parentheses away once I have the number. 4 plus 2 squared times 3. I am done with all the parentheses, but I have 2 sets of exponents. Now, technically, it's not going to change your problem if you do the exponents in the wrong order, but we always kind of do everything in left to right order. So I'm going to do this one first, then I'll do this one, but it doesn't really matter. I'm kind of doing them all in one step. 8 times 8 and 2 times 2. They're both squared. So 8 times 8 is 64 minus 4 plus 4 times 3. All right, so I have a minus and a plus and a times. Well, if I look at step 3 here, multiply and divide is next, and I see that I do have a multiply. So I'm going to go ahead and do that next. I get 12. So in the front, I have 64 minus 4 plus 12. All right. Now I'm on to step 4. I only have adding and subtracting left. I'm going to do them in order from left to right. First, I'll take 64 minus 4, which is 60. And then I will add 12 to get a total of 72. All right, next target. I can identify numbers as prime, composite, or neither. Remember, prime numbers have 2 factors, 1 and themselves. Composite numbers have 3 or more factors. And neither numbers are neither because they have so many factors or only 1. And that would only be the numbers 0 and 1. 0 has an infinite amount of factors. We can't even count them because every single thing is a factor of 0. And 1 can only be divided by itself, which is 1. So it doesn't make 2 factors. It makes just 1 factor, which makes it special and unique. We call it a neither number because it doesn't fit prime or composite. So you can easily see that this number here, we're going to write is a neither number. I'm just going to write an N for neither. Okay. My suggestion for the other numbers is let's go through and try and divide them by the smallest prime numbers. So if I cannot divide it by 2, 3, 5, or 7, more than likely it is prime. Now, obviously, it could go a lot higher with prime numbers, but I'm not going to give you anything that's crazy complicated. I want something that you're going to be able to recognize on your test. So all of the ones that are on the test will pass this test. If you can't divide it by 2, 3, 5, or 7, it's going to be prime. So let's go ahead and try it with 19. If we try and divide 19 divided by 2, it doesn't work. How about 19 divided by 3? That doesn't work. 19 divided by 5 doesn't work. 19 divided by 7 doesn't work. And 19 happens to be prime. I'm going to write a P here for prime. You may use a multiplication table on the test, but you may not use your calculator. So make sure that if you aren't very good at figuring out if numbers are divisible by 2, 3, 5, and so on, which is going to be something we cover in our next unit, that you use that multiplication table to see. So you might have to go down the 2's list and see if you see the number 19. If it's not on there, keep going. Go down the 3's list. If you pass 19, you know it's not on there, keep going, and so on. Okay, 77. Can I divide it by 2? No, it's not an even number. 3? I don't think so. I could do the 3's test that I will be teaching you next unit on divisibility. The 3's test is if you add up the 2 digits. So if I add up 7 plus 7, I get 14. If 14 is divisible by 3, if I can divide that by 3, then 77 also can divide by 3. That didn't work though. More than likely, you're looking at this and you're seeing, I already know if I start big and go smaller, I can divide by 7. This could be divided 7 times 11. I think a lot of you know that one. And so this is going to be a composite number. Going over to 21, I can start small and say, can I divide it by 2? Well, I'm looking to see if it's even, and it's not. Can I divide it by 3? Go down that 3's list, and 21 is on there. 3 times 7 equals 21, so that will be composite. And 59, I'd go down my 2's list, check all the 2 multiples of 2. If 59's not on there, go down the 3's, go down the 5's, go down the 7, and you will find that this is going to be a prime number as well. All right, the last target is prime factorization. I'm going to show you 4 examples of factor trees and how I want you to write the numbers when you're done. So a factor tree is where you're breaking numbers apart until you only have prime numbers left. I like to circle the prime numbers so it's really easy and obvious for me to see when I get there. So I'm going to start with 48. I'm going to think of a math problem that equals 48. It can be any problem except using the number 1. The number 1 wouldn't break 48 apart. It would stay as a 48, so that wouldn't really give us any help. So we could use 2. I see that 2 works because you can divide it any even number by 2. I know 6 times 8 is 48. So I know 4 times 12 is 48. Any of those things will work. Let's go ahead and do 2. A lot of people will start with 2 if it's an even number. So 2 and then half of 48 is 24. I know 2 is prime, so I'm going to circle it. Remember, those prime numbers I want you to have memorized are the first ones, 2, 3, 5, 7, 11, and 13. I'd like you to just have those memorized, that they're all prime numbers. So we know 24 is not a prime number because it's an even number. So let's keep going. We can split that up many different ways, but let's go ahead and use 2 again. 2 times 12. And we could divide by 2 again, 2 times 6. And we could divide by 2 again, 2 times 3. And 3, since 3 is a prime number, we're going to circle that too. And see, we ran out of numbers to split up, so we know that we're done. So I'm going to write this as a multiplication problem, and I'm going to write all the smallest numbers first. Oops, all the 2's first. So 2 times 2 times 2 times 2 times 3. So I'm going in order from smallest to largest. That helps me to see that there's a lot of 2's here. I can write that in a shorter way, and I would like you to. On your test, it's actually going to be matching for this. So you'll see 4 numbers and 4 choices for your answers. So hopefully you see the answer that matches yours. So I see that there are 4 2's. So I'm going to write a big 2 and a little exponent of 4 times 3. And that is the prime factorization of 48. When I go to 120, the first thing that pops out at me is taking this 0 away. So whenever there ends up being a 0 on the end, you know it's a multiple of 10, right? So whatever's in the front times 10 would give you that number with a 0 on the end. So 12 times 10 is 120. That really breaks that up small. So now I'm going to take my 12 and divide by 2, and divide by 2 again. All right, that side's done, but I still have this 10, which is not prime. So I'm going to go on this side, 2 times 5, and 5 is prime. So now I'm done. If I count up my 2's, I've got 2 times 2 times 2 times 3 times 5. So that's my list of primes multiplied. And I've got 3 2's, so that's 2 to the 3rd power times 3 times 5. That's the prime factorization of 120. All right, 2 more examples. Again, I can split this however I want. I'm going to split it as 6 times 6. So I've got 2 times 3, both are prime, and 2 times 3, both are prime. So I've got 2 times 2 times 3 times 3, which is 2 to the 2nd power, times 3 to the 2nd power. 86. I'm going to split that into, let's see, The only thing I really see popping out at me is 2. So let's do 2. 2 times 43. 43. Divide that by 2. 3, 5, 7, 11, 13. 13 might be tricky for you. You could go down the 13s list on the multiplication table, but none of that works. 43 is prime. So this is just 2 times 43. So sometimes there isn't any repeated ones, and it would just be that multiplication problem. All right, thanks for studying with me. Remember, you can watch this video as many times as you want. You can slow it down, you can speed it up, you can pause, you can try the problems yourself. Have a great night, and remember, you can come see me in the morning if you are stumped with any of these learning targets. Have a great night. Bye-bye.